we're in our last topic for section 5.3, which is the at least probabilities. So for probabilities using the phrase at least one something, right? So it was a blank in there, I typed something. So if you see at least one, if you ever see those words, what you're going to do is you're going to find the probability of zero something and use the complement rule. They have to add up to one thing. Okay, so let's take a look at this stuff right here. So I have the associate's degrees, blah, 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 winter, etc. We've seen these before, so nothing new. All right, now I want you to notice something, and I'm going to go find it in here. So we've already found those associate's degrees, graduates. Okay, so I want you to notice that the probability of not cert, we already found it right here. See it? The probability of certification, just make a note to ourselves, cert is equal to this 2116, 21699 there. And then the probability of not cert, we already found, it's 0.7883. Okay, so I just made a note of that right here. So if the probability of cert is 0.2117, the probability of not cert is 0.7883, they have to add up to 1. All right, so what's the probability of at least one certificate? Okay, so see the words at least one? It was right here, at least one. See that? Okay, so we're going to find the probability of no certificates and take it away from 1. So I want the first person to not be certificate and the second person to not be certificate. So that's 1 minus the probability of not cert times not cert. That's 1 minus 0.7883 times 0.7883. Now I'm going to do that with Excel real quick. So this is 5.3 example 9. And then I'll do A right here. So I want probability of, I want 1 minus probability of not cert times probability of not cert. Okay, so that's 1 minus that not cert, 0.783, times that not cert. And there we go, 0.3785 and change, which is just what I said it was right back here, 0.3786. Now, what about 3 graduates instead of 2? What's the probability at least one of the 3? See that word, at least one, will be not, at least one will be getting a certificate. So it's the same idea. You say, okay, I want the probability of at least one cert. That means I want the probability of no certs. So I want the first one to not be certified, and the second one to not be certified, and the third one to not be certified. All of them. So that's the probability of not cert times not cert times not cert taken away from 1. So I'm going to do that with Excel here. I'm going to go back. All right, so this is letter B right here. So I want 1 minus, and I'm just going to put it in quotes here. It's not cert, the probability of not being certificate, not getting a certificate, not being certified. There we go. To the third power, right? Because it's not cert times not cert times not the cert 3 times, and then you take it away from 1. So that's 1 minus, and then the probability of not cert was this guy right here, 0.7883 to the third power. And there you go. See, I said it was 0.50101. Now we've proved it. Yeah, I don't like that. How about that color? Awesome. There we go. So now what about this one for gender? So suppose, for whatever reason, the chances that your children will be girls is 85%. You're going to have 2 children. What's the probability that at least one is a boy? Right? So if you want to see those words, at least one boy. So what you want is the probability of no boys, which means all girls. If you have no boys, you're getting all girls, right? So right, I mean, see if that makes sense to you. So this is the probability of no boys. Let me write this up. This is 1 minus the probability of no boy, no boy girl, and no girl boy. All of those are off limits, right? So I don't want boy, I don't want boy girl, I don't want girl boy. The only other option is girl, right? So I'm going to find the probability of girl, and I'm going to take it away from 1. Well, that's the probability of girl times the probability of girl, which is 0.85 times 0.85, which is 0.2775 if you take it away from 1. And again, you could use Excel, you could use a calculator, whatever, right, to find those numbers. All right, last problem. What about poker? So everybody always wants to know about poker cards. Well, I'm going to show you how complicated it can get very quickly. So suppose you're going to take 2 cards at random. And again, I'm going to do with replacement. I know in real poker you don't do replacement, but what's the probability that you get at least 1 queen? Okay, again with those words, at least 1. At least 1. So at least 1 queen, what I'm going to find is the chances of no queens, right? So that's the probability of, I want no queen on my first card and I don't want a queen on my second card. So I want 1 minus the probability of no queen times no queen. I don't want a queen on the first, I don't want a queen on the second. There's 2 ways you can do this. It'll work either way. So you can say, okay, no queen, that's 48 no queen cards because there's 4 queens, so there's 48 non-queens, times another 48 non-queens out of 52. And that gets you this ugly fraction, and then you take it away from 1, which gets you this, and that's your decimal. Cool, that'll work. Or you could do 1 minus 12 out of 13, because in every suit there's 12 non-queens. So that's a little quicker to think of it as there's 12 other cards for every 13 cards there is in the deck, right? So ace through jack and then the king. So 12 out of 13 times 12 out of 13, that's all the non-queens, and then I take it away from 1, right? So that's another way. You'll get to the same answer, which is 0.1479. Again, I just used Excel or a calculator either way. Equals 25 divided by 169, done. All right, let's do it again, but with spades. What's the probability that at least one of 2 cards selected is a spade? Well, it's the same idea, right? Except it's just spades this time. So you can say, okay, well, I want no spades, so I'm going to find the probability that my first one's not a spade and my second one's not a spade, and take it away from 1, right? Because what I'm really looking for is this probability, at least 1. So I find the probability of none of them, and take it away from 1 because they're complements of each other. Well, spades, you can think there's 39 non-spades in a deck, or if you like, you can say, okay, there's 4 equal suits, 3 of them are not spades. So either way, you'll get to the right answer. You could say 39 over 52 times 39 over 52, take it away from 1. Or you can do 3/4 times 3/4, take it away from 1. Either way, you're going to get to 0.4375 as your final result. All right, let's expand it. What if I do 3 cards? I want no queen on any of them. I want the complement of what I was really looking for. Because what you really wanted was at least 1 queen, a queen somewhere. So if I don't have at least 1 queen, then I've got to have a queen no place, right? Okay, so I want no queen on the first, no queen on the second, no queen on the third. So I find probability of no queen times no queen times no queen. I just went with the 12 out of 13 because it's easier. And that gets you this number altogether once you subtract this from 1. So 12 times 12 times 12 is 1728. 13 times 13 times 13 is 2197. So you subtract that from 1, you get 469 over 2197, and you're done. Okay. Same with the spades. At least 1 spade, but now it's 3 cards. So you say, okay, I don't want a spade on the first. I don't want a spade on the second. I don't want a spade on the third. I find the probability of no spade, no spade, no spade. So I find the chances that all 3 of my cards are not spades. Here it is, right there. This 27 out of 64. That's chances that all 3 of your cards are not spades. If you don't have that, if you don't have it so that you have no spades, then you must have at least 1 spade. It's a double negative, right? Let me write it out somewhere here. This is why this rule works. So let me give it to you. So note: if you do not have no spades, right? Not have no, get it? Not no, double negative. Then you must have at least 1 spade, right? That's why this rule works. If you do not have no queens, here, let me put it this way. Here, let me do it with, I'll skip the queens. Let's go back to the kids here. If you do not have no girls, right? Or no boys. So if you do not have no boys, so here's no boys right here. If you do not have no boys, then that means you must have at least 1 boy, right? not have no boys means you got some boy, right? Some boy, maybe one boy, maybe two boys, who knows? No boys counts as girl, girl. That's it. If you don't have girl, girl, then you have to have one of the others. And one of the others is BG, GB, BB, right? You have to have at least one boy. You got to be in this group if you weren't over here in this group. So when they say find the probability of at least one boy, this one, what you do is you find the opposite. You find the complement, no boys, and you take it away from one. Because together, girl, girl, see this one? Girl, girl, and all these ones make up the full sample space. Okay? And that's what's working down here. You have, okay, here's all the non-spades, then these are all the ones that have at least one spade in them somewhere. So you wanted this one over here, you found this one, no spades, because it's easier, and then you take it away from one. All right, with that, we are done with 5.3. I hope it was enjoyable for you. I'll see you back here later for more lecture videos.